Folks, welcome back. We're going to continue our look here at exponential decay, especially in like a context of a word problem. So let's take a look at number 3. When you breathe normally, about 12% of the air in your lungs is replaced with each breath. Write an explicit formula for the sequence that models the amount of the original air left in your lungs given that the initial volume of air is 500 milliliters. Use your model to determine how much of the original 500 milliliters remain after 50 breaths. Okay, so this is exponential decay because we are changing out the amount, the air in our lungs at a rate of 12% it changes, or we reduce it, the amount of the original air in our lungs. So exponential decay again is A equals P times 1 minus R to the T. Okay, and in this case we're starting with 500 milliliters of air in our lungs. And what is the interest rate here? Or not the interest rate, the percent change. 12% is what we're reducing, so as a decimal, 0.12 to the T. If we simplify this, we'll get A equals 500 times 0.88 to the T. Okay, so in other words, you can say that we're changing out 12% of the air, or we're keeping 88% of the air, right? Two different ways to talk about the same kind of idea here. So there's our explicit formula, okay? And then use the model to determine how much of the original 500 milliliters remains after 50 breaths. So we want to figure out how much of the original 500 milliliters remains. So that means we're going to solve for A here, okay? Which means where are we going to put this 50? Where does that go? 50 goes in for T, okay, the number of breaths in this case. So it'll be A equals 500 times 0.88 to the 50, like that. And so we can go ahead and type that into our calculator. .88 to the 50. So only about 0.84, we'll round to 2 decimal places there, 0.84 milliliters of air from our original breath remain. Okay. Number 4, Ryan bought a new computer for $2,100. The value of the computer decreases by 50% each year. When will the value drop below $300? So again, why don't you guys try and set this up? Let's have you guys go ahead and set up the formula for this, and then we'll talk about how we're going to solve it too. Okay, so hopefully you set up the formula. $2,100 is going to be our P, or initial amount. This is going to be our R, but remember the R is going to be as a decimal 0.50. And when will the value drop below 300, which is our A? Okay, so $300, right? We want to know when that is greater than, okay, our original value of 2,100 times 1 minus 0.5 to the T. Okay, which that 1 minus 0.5 simplifies to just be 0.5 there, right? And now we'll solve, okay? So we'll have to divide both sides by 2,100, okay, which gives us, this actually simplifies to 1/7, okay, and that's 0.5 to the T. We'll use a logarithm on both sides, so we'll say log of 1/7 is greater than log of 0.5 to the T. Bring that T out front. So we'll have log of 1/7 is greater than T times the log of 0.5, and then divide both sides by log 0.5. Okay, so those cancel, and we'll go ahead and put this into our calculator. Log of 1/7 divided by log of 0.5. Oops, missed the 7. Divided by log of 0.5. Again, make sure you close parentheses around that 1/7. And we get about 2.81. Okay, so T, so 2.81 is greater than T. In other words, T is less than 2.81. should be greater than, oh, I know what the issue is here. This log of 0.5 is actually a negative number, so it actually flips the inequality sign around here, so it should be like that. So it's going to be t is greater than 2.81 years is when we'd expect the value to drop below $300. Okay? All right, last one here, we'll do number 5. Try go ahead, pause the video, and do this one. This aspirin one is very similar to the previous one here at number 2. So try number 5 on your own there, see what you can come up with. Okay, so our equation is going to be 400, A equals 400 times 1 minus 0.29 to the t. And we don't know how much aspirin is left in our system after 6 hours. So we'll just say, so that's our formula. And we're just going to plug 6 in for t. Okay, and then solve that. So 400, 1 minus 0.29 to the 6. Oops, I missed a 0. To the 6th. So about 51.24, we'll say. And that'll be milligrams. Okay? In the next video, we will take a look at number 6 about basketballs.